use algebra to solve this equation. Notice in this equation we have a cos x and a cos squared. In other words, it's a quadratic equation with trig functions. How do you solve quadratic equations? Well, you always start by making one side equal to 0. So if I move the cos squared x to the left side, I still have a plus cos x, subtract 1 on both sides, it's equal to 0. At this point, we have two options for solving quadratic equations. Option 1 is you could factor. Option 2 is you could use the quadratic formula. So it depends on where you're at. Maybe you like to factor, so you try factoring first. Maybe you don't like to factor and you go right away to the quadratic formula. If you do try to factor this one, you run into a problem. So don't write this down, but I'm going to show you that if this could be factored, it technically would be an easy one to factor. Why? Because if I was factoring it, the only way that I could get 3 cos squared would be with a 3 cos x and a cos x. That's because the number 3 is prime. That's the only possibility. And if my last number is a 1, the only possibility would be with a 1 and a 1. Now, if you check multiplying this out afterwards, because we're trying to figure out what signs should go there, can you see that you would get your 3 cos x squared, and you would get a 1 in the end? But my outside is 3, and my inside is 1. And if I have a 3 cos x minus a 1 cos x, or if I have a 3 cos x plus a 1 cos x, will I ever get 1? No. So that's how I know that it can't be factored. And if it can't be factored, well, you'd go to your formula sheet. And on your formula sheet, it says, for ax squared plus bx plus c equals 0, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. This part is important because in this part the x is squared, and so you're solving for x. In our question, the cos is squared, so if we use the formula, we would be solving for cos x, not x equals. The b value is negative 1 plus or minus b squared. Or sorry, the b value is positive 1, it's negative b, negative 1 plus or minus b squared minus 4, a is 3, c is negative 1 over 2 times a, which is 3. And so what do we get? Simplify this. Cos x equals negative 1 plus or minus 1 plus 12, square root of 13 over 6. Now I'm going to draw 2 arrows here because there's 2 possibilities. There's the possibility with the plus sign, so that would be cos x equals negative 1 plus the square root of 13 over 6. And there's the possibility with the negative sign, negative 1 minus the square root of 13 over 6. Now, obviously, these are not on our unit circle. So we go to our calculator. And just because this isn't really easy to see what quadrant that's in, is this a positive number or a negative number? You have to do some mental math and estimating just to figure that out. It's going to be positive. And this one is a little bit easier to see that it's going to be negative. But what I'm going to do is I'm going to go to my calculator. I'm going to type that in just to see its value, negative 1 plus the square root of 13. And this is where the fraction button is really nice. Because if I use the fraction button, I can write it exactly as I see it. If I don't use the fraction button, here's a typical mistake. Watch this. Doesn't this look right? What went wrong? I push enter, it's a different number. Whew. It's just the root 13 is the only thing divided by 6, right? You would need to add extra set of brackets on the top. So if your calculator is different, then you might have to go and say, oh, I have to use brackets here before I divide by 6 to get the right answer. Anyways, it's 0.434. So we're going to solve this left-hand side first. What would I need to do when solving? I have to find my reference angle first. Your reference angle is always cos inverse of the positive value. It's already positive, so that part is good. We can go to our calculator. Cos inverse of that answer. And I find out my reference angle is 64.2. Why does it come up as 64.2? Because I'm in degrees. Is this question in degrees? No. Oh. So we have to go to mode. We have to go and change to radians. I need this second cos inverse. I need this answer from before. 1.12. So my reference angle, 1.12. Then my actual angle will be 1.12, and because cos is positive in quadrant 1 and quadrant 4, how would I find my answer in quadrant 4? Go back to my calculator. I would have to go 2 pi minus my reference angle, which was my answer from before, 5.16. Just draw a line in between here to separate these two. So we figured out our first answers for our first value, and now I'm going to go back to my calculator and do the other side. So just change that -1 minus the square root of 13 over 6 to a decimal, -0.768. And now we have a negative value. Couple of things. To find your reference angle, you have to do cos inverse of the positive value. So I'm going to go cos inverse. If I take this answer, can you see that it's negative? So I could either use my arrow key and delete the negative sign, although it's quicker to multiply by a -1. Does that make sense, that multiplying a negative answer by a -1 would make it positive? Right? And whatever you can do to save you time on your calculator helps you on your exam. Get done that much faster. 0.696 is my reference angle. So my reference angle for this one is 0.696. This time I'm going to take that reference angle, I'm going to use my store button again and store it as x, because I know I have to find my answer in quadrant 2 and quadrant 3. So in quadrant 2, it's going to be pi minus my reference angle, and in quadrant 3, it's going to be pi plus my reference angle. So I get 2.45 and 3.84. So what did we just do? We just solved between 0 and 2 pi. We've been making a note of this. Solutions. Between 0 and 2 pi. There we go. Write it down for both of them. We just solved our answers between 0 and 2 pi. Let's go back and reread the question to make sure that that's what they wanted. solve from negative pi to pi. Okay? Well, between negative pi and pi, if we think about our unit circle, that would be positive answers up to pi and negative answers up to negative pi. So that means any answer in quadrant 1 and quadrant 2 will be fine, but answers in quadrant 3 and quadrant 4 we're going to have to change. So how do we go about this? Well, maybe I go back. In the first one, we had cos is positive. Cos was positive in quadrant 1 and quadrant 4. This one's going to be okay. This one we're going to have to take away. And cos was negative in quadrant 2 and quadrant 3, so this one's going to be okay, but this one we're going to have to get rid of. So what will our answers be? X will equal, well, we can keep those ones, 1.12 and 2.45. Can you see the negative 1 in quadrant 4 has to have the same reference angle as quadrant 1, so the negative 1 will be negative 1.12. And for this one in quadrant 3, a negative angle in quadrant 3 is the same as a positive angle in quadrant 2, same value, just one is positive and one is negative, so this one happens to be negative 2.45. It doesn't always work out like that, where you get the same numbers, positive and negative. It will for cos. And there we have our solutions between negative pi and pi. Did we do everything? No, it also asks to determine the general solution, give the answers to the nearest hundredth. There we were lucky. I rounded to the nearest hundredth right at the beginning before I read that, so I just got lucky in that situation. Okay? But the general solution for part B, well, the general solution to solve, and we're solving for x, x equals, find all your solutions between 0 and 2 pi. We did that already. We have 1.2, 2.45, 1.12, 2.45, 3.84, and 5.16. We're in radians, so plus 2k pi, plus 2k pi, plus 2k pi. Where k is an integer. So questions for practice, I want you to do number 14 first, then number 13, then number 12. Yes. Yes, so you could have also used these 4 answers. Sometimes what you have to be careful about is in the restricted domain, or the domain that they give you, sometimes you don't have all of the answers all the way around. So it is often better to say, go back to the ones you solved between 0 and 2 pi. But in this case, negative 1.12 is coterminal with 3.84, right? Or sorry, it's coterminal with 5.16. And the negative 2.45 is coterminal with the 3.84. So they would be fine to use as well.